Hello and welcome back to the tangent ratio, part 2. I'm going to do some actual numerical examples that kind of show you how useful this stuff actually is. So let's say you had a situation like the one I've drawn here. You happen to have a situation where you have a right triangle, and we know that this angle down here is 30 degrees. And I know this length along here is 20. Maybe it's 20 meters. Maybe this is a tree, for example. And I want to know the height of the tree or something like that. And I got these other measurements made. How can trigonometry or the tangent ratio help me find x? Okay, well, here's how we do it. First things first, let's label the sides. So across from the right angle, that's the hypotenuse. Across from 30 degrees, so I just beam my way across, that's where x is, so that's the opposite. And the other side here touching the angle is adjacent. Okay, so I know which side is opposite, I know which side is adjacent, and while the title kind of gives it away, we're going to use tangent. Now we know that the opposite side's length divided by the adjacent side's length is something we call the tangent. So the tangent of 30 degrees, which by the way we've looked up on a calculator and we know it is 0.577 approximately, and this is supposed to be equal to the length of the opposite side, which is x, divided by the length of the adjacent side, which is 20. Well, what we now have here is a nice little equation that we can go ahead and solve. Now, to solve it, I find the easiest way is to make a fraction of the trig number. So I'm just going to put it over 1. And then it's very easy for me to see what I'm supposed to cross multiply and divide. When we cross multiply and divide, we always take a bottom number and multiply it by a top number. Okay, so I know I'm going to multiply these two numbers together, and then I divide by whatever's left, and that equals the unknown. So to get x in this case, I'm effectively going to go 20 times the tangent of 30 degrees. And if I run that through on my calculator, it spits out 11.55. Okay, if I'm working to 2 decimal places. Now, if I wanted to check my work, so this is not necessary, but I want to convince you that what we've done is accurate. What we're saying is if I take the length of x here, 11.55, and I divide that by 20, I should get the tangent of 30 degrees. I should get 0.577. Well, guess what? You do. So we now know that this is the length of x. All right, so let me clear the screen, and we're going to do my next example. Okay, so same kind of idea in my second example. So let me draw you a little triangle here. So let's say this time it's flipped around a little bit differently. Okay, so let's say you got something like that, and there's our right angle. And somebody comes along and says, we know that this angle up here is 25 degrees. And we want to find out this side. We don't know it, and we know this one here is 12. Could be 12 centimeters or meters, whatever. So I look at it and I go, okay, if I label my sides, across from the right angle is the hypotenuse, across from the 25 degrees, this is opposite, and that means x over here is actually the adjacent. So when I set up my trig ratio, well, the tangent of 25 degrees, that is the length of the opposite, which is 12, divided by the length of the adjacent, which is what I don't know. So there's my trig equation. Again, I like to make it a fraction equal a fraction so that I can cross multiply and then divide. So to solve for x, what I'm actually going to do is this. I'm going to take top number times a bottom number and then divide by whatever's left. So 12 times 1 is 12. So what I'm actually doing is this. 12 divided by tangent of 25 degrees. And of course, tangent of 25 degrees is a number we look up on the calculator. It's actually, you should find, if you just want to know, it's about 0.4663 approximately. Anyway, when we run this through in the calculator, you should get 25.73 as your answer. Okay, we got time for one last example. There's one other kind of question that can creep up here. So let's clear this off. And I'm going to draw a triangle here. So let's say I've got my little right triangle. Something like this. There's my right angle. And this time, I know that this side here is 18. And I know the length of this side is 25. And somebody says, I want to know this angle. So how do we find the angles? Well, again, relative to this angle, this is the opposite. And this guy down here is the adjacent. And across from the right angle is the hypotenuse. So I look at it and go, the tangent of angle theta would be the length 18, or opposite, divided by the adjacent side length. Now, when you have a question like this where you know the two lengths and you're trying to get the angle, we use a slightly different process here to figure out the angle. We do what's called a tan inverse of the 18 divided by 25. So you have to figure out how to do this on your calculators. Sometimes you do the 18 divided by 25 and then hit equals, and then go second function tangent, or on some calculators you go second function and then tangent, and then you put in the 18 divided by 25 and then hit equals. So you have to play around a little bit with your calculator. Here's what I got. If I was working to 2 decimal places, I got 35.75. This would be degrees, because this is solving for angle theta. Typically, we work either to 1 decimal place or even to the nearest degree. So you'll have to read what the question wants you to give as your answer. It would be one of these 3. Most likely the 36 degrees. And with that, I'm going to stop, and we'll catch you later.